So in this exercise, we want to estimate the recurrence interval of floods on this particular stream. And the recurrence interval is really useful for engineering purposes because then we can build structures that might mitigate damage from these floods in the future.
Okay. So let's look at this sample data set here.
Yeah, so the best way to estimate a recurrence interval is just to collect data over a long period of time. So here we just have a snippet of 11 years of data for this particular stream.
Okay.
All right, so how do we go about calculating the recurrence interval?
So there's kind of a simple formula that people often use to calculate these things. So if we abbreviate recurrence interval as Ri,
Okay.
we'll write the equation up here,
So Ri, recurrence interval.
is equal to, and it's going to be equal to this variable n plus 1, and I'll explain what that means.
Okay, so n plus 1 divided by,
And it's going to be divided by this other variable m. So n is the number of years that the measurements have been made for.
so essentially just how long you've been monitoring the stream.
Right. And m is something that we call the rank.
Okay.
And so what it is we're gonna demonstrate this by ranking all these max discharges for each of these years.
So this recurrence interval is kind of like the number of years you've collected data, and then over that period of time, sort of which were the largest floods and where were the smallest floods.
Exactly.
Okay, so we need to start by, in this column here, just ranking these from large to small flood events. So the largest floods will have a rank of 1, like this one here.
Okay, so we have our recurrence interval equation here. And we'll notice that for this sample set in particular, that the number of years is 11.
Right.
So n in this case will be 11.
Okay, so n plus 1.
So we have 11 plus 1 in the numerator and then m in the denominator. So we just end up with 12 over m.
Okay, and remember m, that's our ranking, so we've gone through and ranked all of these.
Okay.
So basically we just need to kind of plug and chug here, 12 divided by our ranking number for each of these flood events.
Okay.
So let's start, for example, with this one. So we have our recurrence interval is going to be equal to 12 divided by our rank
In this
of
case,
1.
it's 1.
Okay, so 12 divided by 1, that's just 12. And we're talking about units of years. So for this large flood, it's going to happen about every 12 years.
Okay. So that was the large case. What about
Right.
the smaller case?
So I'll just start up at the top and we can do the same thing. So here we have our recurrence interval, 12 divided by the rank. In this case, it was 10. Okay, so 12 divided by 10.
So that ends up to be 1.2.
1.2 years.
So this kind of makes sense. The
Right.
smaller case is happening every 1.2 years approximately, and the large case every 12 years approximately.
Okay, so let's go in and fill these out.
Okay.
Okay, so here we've gone through and we've calculated our recurrence interval for all of our flood events.
Okay. So we want to notice that the larger discharge events are expected to happen less often than the smaller events.
Right, so our smallest flood is going to happen about every year, whereas our largest flood happens every 12 years. So we can use this information and extrapolate out to maybe lengths of time that we haven't collected data, say the 100-year flood. Okay, so in our table of recurrence intervals, we had a fairly small span of recording time. We were only recording for about 11 years. But for engineering purposes, we want to look over longer time scales, say the 100-year flood event, which, as we saw from our trend, is going to be a much larger volume of water in a given time.
Okay, so if we were going to plot this up, this type of data, we have here the vertical axis, which is max discharge, which was the measurements that were being made.
So that's our flood water volume in time.
Right, and the horizontal axis is recurrence interval, which was the equation that we used to calculate such things. And so if we wanted to, say, have an example here, we could take the largest measurement of max discharge, and that was 2030 cubic feet per second.
Right.
And it had a recurrence interval of would be expected to be 12 years.
Right, so we're going to plot the 12 years on this x-axis, and notice that it's in log scale.
Right, so it gets a little tricky here, but we want to have 2030 on the y-axis and 12 on the x-axis here, and so that ends up to be about right here.
Okay. So that was our maximum flood event corresponding to about 12 years on this log scale.
Right.
Okay, so we need to go through and plot all of these points then.
Okay.
Okay, so we've plotted all of our data on the graph of maximum discharge versus recurrence interval. And we talked about how, because we have a limited span of data, we only have up to 12 years. But what we'd like to do for engineering purposes is look beyond that and say, you know, what's the discharge for the 20-year flood, the 100-year flood, so that we can engineer structures to try to mitigate damage.
Okay, and one way to do that is to try to fit like a linear line to this data, and then we can extrapolate past the 12 years.
Okay, so let's try to do that.
Okay, so if I drew a line through these points of what I think maybe the best fitting line would be.
Yeah, so we're just going to eyeball it here.
Something like this.
And we're going to assume it's pretty straight. It looks pretty straight.
Yeah.
Okay, so with this data, we can now look beyond our actual collected data and extrapolate beyond to, say, the 20-year flood. So the 20-year flood would probably fall about here on this line.
Okay, so and if we have the 20-year here, we want to know what the max discharge rate would be at that 20-year point. And so that looks to be about somewhere 2,200 cubic feet per second.
Okay, so that's for the 20-year flood.
Right.
Okay, now we want to look out to, say, the 100-year flood, and we can expect this one to be bigger. So the 100-year flood is going to be about here.
Sort of at the end there? Okay.
Yeah.
So, and that, it looks like it's about 1, 2, 3, maybe 3,300 cubic feet per second.
Ah, okay. All right, so much bigger discharge rate.
Okay.
All right, now we can kind of look at the back end of this. Let's say that we wanted to build a structure that could contain a discharge of 2,500 cubic feet per second. So how often is that flood going to occur?
Okay, so we want to know what the recurrence interval might be for a flood that has a max discharge rate of about 2,500 cubic feet per second. So if we look on our y-axis at 2,500 and we follow that across here, it seems to intersect the line about right there.
Okay.
Okay, so now we want to know what our corresponding x value is for this to figure out what the recurrence interval might be.
Right.
So if we draw a line down here to the x-axis,
So it kind of nicely follows this grid line.
it looks like it intersects at about 40 years.
Ah, okay.
So for this type of event, we might expect the recurrence interval to be 40 years.
All right, great.